Okay, I'm going to talk about a few of the components that we work with during a solar installation. I think I'm going to start with the mechanical side, just because that maybe gets overlooked. We talk about electrical, and that's where the certification is. But to accomplish a solar installation, there's a big mechanical component too, and that's how are you going to get these solar panels on the roof, attached, and staying well. And it turns out that there's racking systems that are engineered specifically for this to meet the building codes for both wind load and snow load to ensure that the solar array is going to stay there. So this is a rail. This is a short piece of it that I could use here, but usually they're 8 feet long. But this is a rail that is part of the system. And it starts with attaching to the roof. If you happen to be fortunate to have a standing seam metal roof, then we have clamps like this that slide down over the seams and clamp onto it. Nice benefit of that is there's no penetrations into your roof to hold the array on, but this is the starting point if there's a standing seam. This is just another version of a standing seam clamp, a different brand. But then there's an L foot that goes onto that. The rail then attaches to the L foot, and there are two pieces. It's just kind of a little unwieldy, but I'm going to just explain it. There's then the solar panel set down on this rail, and there's a mid clamp that goes between the panels to hold them together and hold them onto the rail. And then there's that go on the ends of the rail to also hold the panels down. There's also a little slot here for the wiring between the solar panels to kind of call it wire management to keep it tidy inside there. But all of these components, that's frankly a good chunk of the installation time and manpower is getting to the point that these rails are securely attached and ready to accept the solar panels, and then adding the solar panels to it. That's a lot of what the man hours is doing that. The electrical part is then the other, getting that power of the solar panels off the roof is the other component of it. But both are essential. That's the mechanical part I wanted to on. I think now I'm going to switch to just a little example of a solar system. I don't like that word because it means something else, but photovoltaic solar equipment. So
before you do that,
yeah.
what you said that system attached to a standing seam roof. Can you explain what that is?
So a standing seam is really common now on particularly new installation or when people re-roof, and that's a metal roof that when you look up at it, you see these vertical ridges, and the panels are 16, 18 inches wide, something like that, and they run lengthwise up the roof with these seams that attach the two panels to each other, and they interlock, which makes them very watertight. But that ridge, we call it the seam that sticks up, gives us something to clamp to with our clamps and not have to drill holes in the roof to hold the array on. So from a solar perspective, a standing seam roof is a no-brainer. Now there's other reasons to choose your roof type that maybe we just have our one be on the solar side. If people ask, I would always say standing seam, but then they get to decide cost and aesthetics and things like that. But it seems like up here in the San Juans that a new home or a re-roof is more than likely it lasts. There's a lot of benefits. So on the solar side, I have just a little system here that's actually, believe it or not, indoors through a window, and it's somewhat cool that it's even doing that. But I have a flexible solar panel. This is very small compared to what we would on a home, but this is exactly what we might install on a boat or an RV, which is something else we do. We didn't put a picture of it, but that could be an off-grid application, is a boat or an RV. So this is just a 50-watt panel whereas we might install 10,000 watts on a home or 20,000 watt farm, or a big farm barn or something like that. So this is very small compared to the structural solar arrays. So, but the principles are the same. So what we have in the solar panel is we have a couple of wires of that, and it's connected to a battery right here. And at the moment, it's charging that battery. And the principle is when the sun is shining, the solar is providing power to whatever's plugged into it. There's actually a light plugged into it, right? And the solar is providing that power while charging the battery. And then at night, when the sun goes down, the solar isn't doing anything. The power is still provided by the battery. So they just work in conjunction with each other. What's kind of interesting, does the light show up very well on this? I don't know, can you actually tell that it's on? It's really obvious to me, but on the camera.
When it's just the right angle, you can see it.
Yeah, well, so just to illustrate that this is really solar, I'm gonna disconnect the battery from the solar panel. So now it's going straight from the solar panel to the light. There's no battery and it's still even changed. One other cool thing about this, and I think this is the most interesting part of the system for the electrician, and that's this blue box, which is called a charge controller. And what's key is that in order to charge a battery effectively, the solar panels are designed to have higher voltage than the batteries. Otherwise, the voltage is lower than the battery. They're not actually charging it. But they don't. They're intentionally much higher. And the charge controller takes that power from the solar panel and reduces the voltage down to precisely what the battery wants. And it goes one more step, and that's when the battery, it reduces the voltage even more. So it's not really charging the battery, but it's keeping it just topped off. Because if you didn't have a charge controller, and this is sort of the difference between is often the charge controller is left out. But if you don't have a charge controller, if the sun is shining brightly and your battery's already full, then you start overcharging the battery, and it will shorten the life of the battery dramatically. So the charge controller is the key part that makes this work well. It's also the part that's changed the most in the last 10 or 15 years, becoming more efficient, more advanced, more custom. You can change the settings to be more precise. So that's where the installer is actually spending their time, is getting charge controller set up correctly. The wiring is fairly established. When they come to a project, getting the wiring from the solar panel to the charge controller, they know how to do that before they even arrive for that. But then the charge controller, they're going to spend some time thinking about, well, what type of battery do I have? How big is the battery? What should the voltage be for that? And they set those accordingly. So I think I may have, actually I have one other piece I wanted to show. And that's, in the solar industry, we were used to have solar panels wired together, wiring coming off the roof to a big inverter that converts that DC power to AC power, which is what your home runs off of and what Opalco uses. So if you're sending power back to them. And that was the way it was. But what we found is that there's better ways to do it. And particularly in places with partial shading due to trees, which is super common in San Juan County. Most sites that I go to have some shading due to trees at some part of the day. So one of the solutions became what's called MLPE, which is module level production. Module level power electronics. Sorry, I just MLPE. I don't say that whole thing very often. Power electronics. So this is now installed on the back of each solar panel, and it does the conversion from DC power to AC power right there at the panel. That's called a microinverter. And it does a couple of things. One is it eliminates the partial shading problem because each panel operates like its own little power plant. It doesn't care what the rest of them are doing. It also means that from a safety standpoint, and this is where the electricians come into it, and with following the National Electrical Code, from a safety standpoint, this enables the solar panel to be turned off at the panel, or at this module. So there's no electricity in the wiring that's left the solar panel and headed down off the roof. That's how it used to be. If the inverter was on the ground or on the wall, when you turned off the inverter, yes, there was no electricity coming out of the inverter, but there was still voltage in the wiring from the solar panel to the inverter as long as the sun was shining. Well, that was considered a safety problem, and the National Electrical Code was updated to say, no, that needs to happen right at the panel. It's called shutdown, so that anytime you turn off a switch for solar, the power stops at the panel, and these were added in part for that. So this is another component that an installer would be adding. This little slot enables them to be attached to the rails underneath the solar panel, and then just plugged in with the MC4 connectors that an installer electrician would know how to assemble these. They don't come necessarily with these attachments on them. They might be cutting these wires and adding the connectors themselves. Okay, I think I may have covered what I wanted to cover. If there's questions, I would be happy to answer them.